So the big day is approaching. The project is almost here. Let's see, that's due on Wednesday of next week. And then, of course, the week after that is Thanksgiving. So we don't have school the week after next. And then the week after that's the last week of the semester. So we're really getting close to the end. I think this being class 37, if I remember correctly, we get to 42 by the end of the semester. So we're almost there. We'll do a little bit today to start making the point that it would be good to refresh your memory on the earlier topics from the first part of the semester to prepare for the final exam. So the kinds of things that you should be thinking about is the project, preparing for the final exam, and then also the new material that we're talking about. We'll do a little bit more with depreciation today. So before we get into that, anybody explain why companies like depreciation? Yeah.
They get like deductibles on it.
That's right. Deductibles against what?
Tax.
Taxes. Yeah. So companies like depreciation because it reduces the amount of tax they have to pay if they get credit for their equipment wearing out. So remember, there's a big distinction between the equipment actually physically wearing out, which they don't like, and then this accounting idea of depreciation. And sometimes the two are related. So occasionally the depreciation class life is aligned with the actual expected useful life of the equipment. But in then other cases, it isn't necessarily aligned. And what companies want is they want as much depreciation as they can get as fast as they can get it. Because money now is more valuable than money in the future, so they want to depreciate the value of their equipment as quickly as possible to reduce their taxes now. So companies like depreciation. What we're talking about today is MACRS, the Modified Accelerated Cost Recovery System. What are the two depreciation types that we talked about in class on Wednesday? Straight line, that's right. The other is declining balance. So the Modified Accelerated Cost Recovery System is a combination of the two. So we'll talk about that today. So some of the ways that it's unique from either of the two that we've already talked about is that in the Modified Accelerated Cost Recovery System, the value always depreciates to zero. So it's expected that there's no salvage value regardless of the equipment. And companies like that because they wouldn't want their depreciation to be anything less than the maximum value that they spent. Even if they're going to sell the item for scrap or if they're going to resell the item at the end of its class life, they still get to depreciate all of it. So they like that. The way it works is that it switches from declining balance with a 200% slope, meaning that in the initial years it is depreciating twice as fast as it would during straight line depreciation. And then at the end it switches to straight line depreciation so that it ends up with zero salvage value. So companies like that it depreciates to zero. They also like this part of it. The part of it that they're getting more depreciation early instead of it being a linear process of the same amount of depreciation every year. So for them it's the best of both worlds. They get more depreciation now when the value is greater, and then they also get it to depreciate to zero. So I guess it's special interests at work, the fact that this Modified Accelerated Cost Recovery System has become the dominant accounting method for handling depreciation. Rather than having to have like a negotiation process or it being like brand dependent, the way it works for the recovery period is it's just based on the classification of the equipment. So you and I probably know that Hondas have a reputation of lasting for a really long time. And there are other car brands that have a reputation of not lasting as long. I don't know, what's a really unreliable car brand?
Jeep.
Jeep. Good one. Yes. I have a Jeep and I can attest to that. My son drove a Grand Cherokee in high school, and man, he beat the hell out of that thing. It's just, it's really suffering. So we know that probably the Honda is going to last longer than the Jeep, but the modified accelerated cost recovery system says automotive equipment all depreciates for a class life of 3 years, and if we use the GDS system, it's 5 years of depreciation. So it doesn't matter the brand, but it's just based on the category of equipment. And then this is the strangest thing about the system is they've already given companies a lot of things that they want, like depreciation 0, the steep slope up front. The one thing that they did to kind of protect themselves against abuse is this N+1 thing, the half-year convention. So the reason for that is, say you're a company and you know you're going to have to buy a vehicle, and what if you bought it on December 31st? What they would do is they would take a whole year of depreciation even though they only owned it for a single day. And so the government didn't want people abusing that aspect of depreciation, like loading purchases towards the end of the fiscal year and then, kind of playing games with how much depreciation is taken early on. So this half-year convention kind of it puts a cap on that in a sense, because the way it works is the first year that you buy the equipment, you only get a half share of depreciation. So then that kind of removes the incentive of doing it at the end. It's, I think, just in recognition that some people buy equipment early in the year, some people buy equipment late in the year, and so because of that, the average would be that people are buying equipment in the middle of the year, so therefore you only get a half share of depreciation in the first year of ownership. And so then what that does is it actually pushes that extra amount of depreciation into one additional year beyond the class life. So this is a really strange thing. If they say it has a 5-year class life, if you look at the number of rows, there's actually 6 rows, because it's a 5-year depreciation, but you get half a year of depreciation in the first row, and the last year is also just a half-year depreciation. So you'll see what I mean by that in a moment when we look at some examples here. But these are some of the class lives and recovery periods, and so this is illustrating how they've taken the wiggle room or the hand-wringing out of determining what should be an appropriate class life and recovery period. So for instance, if you buy equipment for mining equipment, if you're using the GDS recovery period, which is the most common, you'd have 7 years that you can depreciate the equipment over. And I'm not exactly sure why there's this difference between class life and recovery period. I think it's probably another illustration of how the special interests had even faster depreciation according to the GDS. And so you just see different equipment is expected to last longer, and so has a longer recovery period. So for instance, gas utility distribution facilities. So those are kind of like where a gas pipeline has the pipeline coming up, and then there's a booster pump that is adding the energy to send the natural gas further down the gas pipeline. That stuff's pretty durable. It lasts a long time, and it has a recovery period of 20 years. But then there's other equipment like a tractor unit for use over the road. I think that means like a semi-truck. Would have a 3-year recovery period. So much faster breakdown of the equipment, and therefore a much lower recovery period. So here's the way it works. Once you know the amount of depreciation that is available, which is the cost basis, including sales tax, including training, including delivery charges, so that entire initial first cost, then you'd multiply it by each one of these fractions to know how much depreciation you take in a given year. So if it's got a 3-year recovery period, according to the GDS system, then something would get 33% of its depreciation in the year 1. You can see 44% of depreciation in year 2. And now what it's doing is it's switching over to straight line eventually, where you're getting this year 3 is the straight line depreciation amount, and then year 4 is the half year share that you get. So I think the half year effect is maybe even more visible in the 15 year. So look how in year 1 it's 5% of the value. In year 2 it's pretty close to 10% of the value. So if it had been a full share in year 1, then it would be a 10% reduction for double declining balance. But then it switches to straight line depreciation. And so notice how it says 0.059, 0.059, 0.0591. Like they're just kind of, it's going from 0.059 to 0.0591 so that in the end it adds up to exactly 1. So some of it is, like that little transition from 0 to 1 is so that it all works out in the end. But you can see the straight line component of it is just there are several years where the depreciation amount is the same, whereas there was previously a double declining balance slope where it was steeper, more depreciation per year than the straight line amount, and then in the terminal year, in the last year, it's just a half share of depreciation. So it's easier than what we were doing in class on Wednesday. We don't have to calculate lowercase d. We don't have to calculate the depreciation quantity. No formula is required other than just multiplying this by the initial cost basis to find out the depreciation amount. So here's how the system works. You'd know the depreciation amount for a given year by multiplying the cost basis by the fraction from that previous table. So d, lowercase d sub t, the depreciation rate for a given year is what you get off of this table. So this is lowercase d sub t, the depreciation rate for a given year. And so then if you want to know the book value in any given year, it's just the initial book value minus the cumulative depreciation over all the years that have occurred up until the year that you're interested in. So this is still the same idea for determining the book value. So as an illustration, let's say that a company spent $238,000 to purchase a bus, and we want to find out how much depreciation there's going to be for every year that follows its purchase using the GDS method. So first thing we'd have to do is find out what category the bus is in. So this bus is in the category 00.23 asset class. And so it's a bus, and what we can see from the GDS recovery period, we should do the depreciation over 5 years. Okay, so let me copy this into Excel and illustrate to you how we would find out what the depreciation amount is for each year and the cost basis. Okay, so our initial cost basis, B, is $238,000. That's our cost basis. And we're going to have 0 through this being a bus and it being a recovery period of 5. That means we actually need to have 6 years on the diagram because of the half-year convention. So let me have this go down through 6 years. There we go. Oh, it just really doesn't want to move. Ah, there it is. All right, so we're going to have, for each year, determine the depreciation amount for that year. Well, this D will be the depreciation factor. And then we'll calculate the depreciation amount. And then we will have the book value at the end of the year. All right. So at time 0, that's when you first buy the equipment. The book value is the initial cost basis. Okay, the depreciation factor for year 1, according to this table, is for the GDS system 0.2, then 0.32, then 0.192, 0.1152, 0.1152, and 0.0576. So I got those off of this table. I know it's a little bit probably hard to see. I'll give you a copy of the table in a moment. It's also in the book. Okay, so then the depreciation amount for every year is just the initial cost basis. So I'm anchoring the reference because I'm always going to refer up to that initial cost basis multiplied by the depreciation factor. So we can see how much the depreciation is for every year. And what we know is that we should be taking the entire value of the item to 0. So the sum of the depreciation should be the same as the cost basis. So let's just check if the sum of the depreciation is equal to the initial cost basis. It is. And that's good. Now what we can do is we can say that the book value at every year is the previous year's book value minus this year's depreciation amount. And then that way, when I drag it down, it's always going to look at the cell above it for last year's book value, and then it's going to subtract out the depreciation amount that's available for this year. So this is showing how we started with $238,000 of book value because we bought this bus, and then its book value is going down to 0, and so this depreciation amount is how much the company is going to be able to write off for their taxes. And so if they made, for example, if you had a bus company and you made $50,000 of profit by operating your bus company, what you could do is you could say, well, I've got $50,000 of profit. Normally I'd have to pay I'd have to pay tax on that $50,000. But I've got $47,600 of depreciation. That means I only have to pay taxes on $2,400 worth of profit. So it reduces your profit because honestly, you had to buy the equipment in order to operate the business, and so it is an operating expense. And over time, as the depreciation went down, a greater share of the profits would become taxable. But early on, the company's able to, actually in the second year, it'd be even more. You know, they may have depreciation that exceeds the value of their profits. And I'm not sure exactly how that works. I think in some cases you can carry over depreciation that's unused into a future year. But consult your tax accountant on that one. I'm not exactly sure how the situations in which depreciation carries over and that which it doesn't. I do know that this system is simpler for us to use than calculating the depreciation factor like we had to for double declining balance. So does anybody have any questions on this illustration? If not, then I'm going to give you today's in-class exercise. Let me bring the problem up on the screen as well. So on the front side of the paper is a depreciation. No, that's not it. On the front side of the paper is a depreciation problem. Well, let me just hand this out while the computer's thinking.
I'm also assuming that because that's not the only data. Because I don't know. But also, listen to this, they're only doing it with experience.
So the first side has depreciation, and then on the back of it is just kind of some refresher problems. Going way back to the classics, the time value of money. You know, find P given A, find A given F, that kind of stuff. So if you want to check your calculations on that first problem, they're up on the screen.
Well, I don't think that's right. I just guessed. But I feel like if you bring that to the future, it means it does the same thing. Either way. It would be the same thing. I don't know.
On the midterm exams, I sometimes took off 1/10 of a point for certain issues. I don't know if any of you had 1/10 of a point deduction.
Yeah.
So like pretty common thing would be a 10-point problem, and I took off 0.1 points just to get your attention, just so that I wasn't making a suggestion or a request that was ignored. And so the reason I bring it up is on the final, it won't be 1/10 of a point deduction if you do something like use the incorrect number of decimals in your factor. Like if you're using the equation method, like this is the equation method, your answer should be accurate to the nearest penny. And so it would be a mistake if you just rounded off your factor to like 0.722. If you said 0.722, then you wouldn't be able to express your final answer to the nearest penny with accuracy. So the midterm, it was 1/10 of a point deduction. On the final, I'm not going to give you a 0, it may be 1 or 2 points deduction. So I hope it's a lesson that people have internalized, the idea that you need to be precise to the penny on equation method problems. So like with that said, this one obviously is a find present value given some future value, and then knowing how to interpret the fact that here I'm saying it's an inflation rate. Well, just because it's an inflation rate rather than an interest rate, you can still put it into this formula. And we normally would give the variable f for inflation rate. If you remember back to when we were talking about that, it's okay to put it into this formula. I wrote the formula just in terms of the way we're used to seeing it. The equations that are here always has I for an interest rate. You could substitute the letter f if it happens to be an inflation rate. And in this one, what we were doing is finding the present value of purchasing power, which is why we accounted for inflation. So you can see that that $85,000 you're going to get in the future is kind of like getting $61,424 today. Any questions about the first one on the time value?
Not for the specific problem, but on the exam, if we use the equation method and we're off like within a cent, is that going to be a problem?
No. Like 1 cent is not a problem. Yeah. So if you said 36 or 38, I'll still be happy enough with that. Yeah. Okay, problem 2. They always try and get you with the interest. They just tell you how much the payment is and try and hide how much you're actually paying for the item. Car salesmen do that. They just think in terms of, oh, do you think you can make a $400 a month payment? Yeah, I guess. Okay, well, we can do a $400 a month payment for 84 months. And then you never really know what is the effective cost of the item that you bought if you're only thinking in terms of the payment that you can handle. So here, they're trying to pull that trick on you. They're just saying, okay, you're going to buy the furniture with a store credit card. You'd be lucky to get an interest rate of 12%. That would be an unusually low interest rate for buying stuff like furniture. But let's say it's 1% per month, which is what this means. If it's a nominal annual rate of 12% and it compounds monthly, that means that the interest rate per period is 1%. So if you go to the factor table that I provided, the 1% factor table that was on the back side of the paper, for n equals 30 months at 1%, then the factor is 25.8077. So if you're having $224.45, you've got 25 of those, which is basically finding the present value of the 30 payments, then it turns out that you're paying $5,792 for whatever this is. Hopefully it's a really nice leather couch. Because if it's anything less than a super nice leather couch, you probably overpaid. So that is how we, number one, account for this idea of nominal annual interest, but then monthly compounding. And then this is just another classical find P given A. Any questions about this one? So let's see, how many significant figures do I have? If this factor was 25.8077, it's 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. I can report it to the nearest penny because this is one of the rare factors that actually has a lot of digits on it. Okay, the last problem. Buying the work truck today for $65,000 and then sell it in 7 years. So capital recovery is the annualized difference between the purchase price and the salvage value, or the resale value sometime in the future. So the initial purchase price is an outflow, the salvage value is an inflow, and I'm going to have to take the difference between the two because I'm paying the $65,000, but I'm receiving the $18,500. So the annual revenue I need to receive to cover that cost is going to be the annualized difference between those two things. So I've got the factor for find A given P at 6%, and find A given F at 6%. So I've got two of these factors. And I find that the annualization of the purchase price is $11,600. The annualization of the salvage value is $2,200. So the difference means that I need to earn $9,439 each year in new revenue to cover the capital recovery. Yeah.
Would it be acceptable if we discounted the future to the present and then found the A that way?
Yes.
Okay.
Yeah. So you don't have to go from P straight to A. You could take the P, you could take the F to P and then annualize it. That's fine. Yep. Other questions? All right. I'll stick around for a few minutes if anybody has questions on the project. Otherwise, I'll see you on Monday.